Hello everyone. Okay, so today we are going to do example number 3. And for this question, okay, first please read the question carefully. Okay, as seen in the question, this time for example number 3, the question is little bit different. Okay, if you still remember in example number 1, we don't have h exponent j omega compared to example number 2. Okay, in example number 1, what you need to do is actually you just need to convert from continuous time signal to discrete time signal. For example number 2, you need to convolve, you need to multiply with h exponent j omega. In means your h exponent j omega is unity magnitude response. Because of it is unity magnitude response, your h exponent j omega is equal to 1. So basically you can just multiply x with h so that you can get y exponent j omega. That's it. Okay, but this time around, for example number 3, your h exponent j omega is actually low pass filter, right? So basically you need to apply some mathematical technique, which is interpolation technique. Right? So if you read the question again, okay, this time around you have the block diagram, the system. Consider the system in figure 1. Okay, so you will have the block diagram. Okay, so you have SAT is your input signal, and then you have to convert from SAT become XN. After that, you have to go through h exponent j omega. So if you read the question carefully, your h exponent j omega is actually the low pass filter. Okay, this one can be seen in figure number 2. For you to get yn, and then yn need to go through another converter to convert from digital to continuous time for you to produce yt. Okay, so your input is SAT. And in the question, it states your Fs is equal to 500 sample per second. Okay, so first question, determine if aliasing occur as plain. Okay, so for you to answer for the first question, what you have to do is, first you have to identify what is your first message frequency value and what is your second message frequency value. Okay, so for you to answer what is omega m1, what is omega m2, you have to look at your SAT. SAT, this signal is coming from XT convolved with your impulse tree. Okay, so you get your SAT. So your first message frequency is 100 pi. Your second message frequency is 400 pi. So what you have to do next is you need to find what is your omega s. So where to get your omega s? You can get from 2 pi Fs. So your Fs value is 500. So your omega s value is 1000 pi. Okay. So what you have to do next is you have to remember your Nyquist theorem. In Nyquist theorem, it is said that your omega s must be greater than 2 omega m. Alright, so for this condition, if your omega s is greater than 2 omega m, it is oversampling condition. means if it is oversampling condition, aliasing not occur. Alright, so this is for the first condition. For the second condition, omega S is less than 2 omega M. This condition is undersampling condition. For this condition also means aliasing occur. Okay, and then we have third condition, omega S equal to 2 omega M. This condition is critical sampling. So basically for this condition, this is considered as ideal condition. Why? Because of your omega S value is equal to 2 omega M. That's why this one is considered for condition C. This one is considered as ideal condition. Okay, so for you to answer question A, what you have to do is you have to check one by one. Alright, so what you have to do first is, okay, so for first condition, when omega M1 is equal to 100 pi. So basically from here you know that your omega S value is greater than 2 omega M1. So aliasing not occur. Okay, for second condition, omega M2 equal to 400 pi means your omega S is greater than 2 omega M2, right? Okay, so aliasing not occur. Since, therefore, since both omega M aliasing not occur, then aliasing not occur for this system. Done. Okay, this is for part A. Okay, now we move to question B. Alright, so the question is, sketch the spectrum of SAT, SN, YN, and YT. Make sure you identify the important points. Alright, so for this question, you are asked to sketch the spectrum. Spectrum so when you see the keyword spectrum, definitely you know that you have to do Fourier transform, right? So first we look at your SAT equal to okay, so what you have to do first is you need to find the CTFT of SAT. So CTFT of SAT is Saj omega. 4 remain 4, okay, because this one is amplitude, or in other words it is a constant. So Fourier transform of constant is constant, and then we have cos 100 pi t. So Fourier transform of cos 100 pi t is cos pi delta omega minus 100 pi plus delta omega plus 3 pi delta omega minus 400 pi plus delta omega plus 400 pi. Okay, next we have to sketch the spectrum. So don't forget to label your graph. Okay, again, if you forget to label your graph, don't forget to put the marks for you. Alright. Okay, so delta omega minus 100. So we have here, this is 100 pi, and then we have minus 100 pi. The amplitude is 4 pi, and then we have at 400 pi, and then at minus 400 pi. Amplitude is 3 pi. Then for spectrum XAT, okay, next we move to XN. Okay, so for you how to get SN, you need to remember the ecosystem from continuous time to discrete time. Okay, so because of that, okay, now it is the ecosystem from continuous time to discrete time. So what you have to do is, you need to replace your T with NT, right? So what you have to do next, okay, you have to refer back to your SAT. So basically you have your SN equal to, okay, don't forget to put your 1/4. Okay, why? Because of 1/4, it is actually referring to your sample signal, which is coming from your sampling process. Okay, so we have for cos 100 pi, you replace your T with NT. So now you will have NT. Okay, plus 3 cos 400 pi NT. Okay, how to get your T? T is equal to 1/Fs. So it is equal to 1/500. Alright, so your Sn is equal to 4/T cos 100 pi divided by 500 is 0.2 pi n plus 3/T cos 0.8 pi n. Okay, next you have to sketch the spectrum. Okay, for you to sketch the spectrum, you have to determine the DTFT of Sn, which is x exponent j omega equal to 4 pi over t delta. Okay, instead of you use capital omega, now in DTFT you have to use small omega minus 0. Okay, next what you have to do is you need to sketch the spectrum of x exponent j omega. So yeah, the spectrum of x exponent j omega is, okay, again don't forget to label your graph. Okay, so first we have at 0.2 pi, and then 0.8, sorry, minus 0.2 pi, and then we have 0.8 pi, and then another one is at minus 0.8 pi. Okay, so this one 3 pi over t, the above is 4 pi over t. Okay, this is discrete time signal. So for discrete time signal, the signal is periodic at every 2 pi, means the signal is periodic for every, from the range is periodic at every 2 pi, means the signal will be repeated for every minus pi 2 pi. Okay. Okay, so this is for x exponent j omega. So what happened to your yn? Okay, so if you look at your question, okay, we have Sn, and then going through h exponent j omega to produce yn. But this time around, your h exponent j omega is in terms of low pass filter. So what you have to do next is, this one you need to do interpolation technique for you to get your y. Okay, so how to get y? Y exponent j omega is equal to x exponent j omega times h exponent j omega. Okay, so this equation you get from chapter 3. So I hope you open back your notes on chapter 3. Okay, so what you have to do next is you need to find your y. So basically we need to find the amplitude for each point, for minus for 0.2 pi and 0.8 pi. Okay, okay. So what you have to do next is you need to find the amplitude of 0.2 pi and then add 0.8 pi. Okay, so I name this one as not A and B. Okay, so why we just find A and B at the positive side, at the negative side we didn't find any values for each amplitude because of, okay, if you look at this diagram, okay, it is actually the same signal. Okay, it is actually the overlapping signal, symmetrical at 0. So basically, okay, these two is actually the same signal but at different direction. Okay, this is at the positive side, this is actually at the negative side. Okay, this is at the positive side, this is actually at the negative side. So basically the signal is the same signal but at different direction, at different position. Alright, So basically, okay, go back to the question. Okay, so we apply the interpolation technique. So use interpolation technique. To find A and B. Okay, so A is equal to pi minus 0.2 pi. Okay, pi minus 0.2 pi times 1 over 5, 1 over pi. Okay, y over x. So 1 over pi. So the amplitude of 0.2 pi is 4 pi over t. Alright, so you will get 2.2 pi over t. B, how to find B? Pi minus 0.8 pi times y over x, 1 over pi, times, okay, the amplitude of 0.8 pi, the signal is 3 pi over t. So you will get 0.6 pi over t. Okay. So from here you know that this is the amplitude of y exponent j omega signal. Amplitude of y exponent j omega signal. Right. So what you have to do next, you know that from here you know that your y exponent j omega is equal to 3.2 pi over t, okay, at omega minus 0.2 pi plus delta omega plus 0.2 pi plus, okay, next 0.6 pi over t delta omega minus 0.8 pi plus delta omega plus 0.8 pi. So this is the equation for y exponent j omega. Okay, now we want to sketch the spectrum of y exponent j omega. Okay, so we sketch the spectrum. We have omega, and then the y-axis is y exponent j omega. Okay, so at 0.2 pi, and then we have at 0.2 pi minus 0.2 pi, the amplitude is 3.2 pi over t. Next we have at 0.8 pi and at minus 0.8 pi. The amplitude is 0.6 pi over t. Okay, and again don't forget to put dot 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 because this one represent periodic signal. Okay, repeated at every minus pi to pi. Okay, then for y exponent j omega, then we move to, okay, we want to find, okay, we have your yn. This is our yn. Okay, next is goes to another converter to find y. And again, you have converter. This time around, you need to convert from discrete time to continuous time. Okay, so for you to convert from discrete time to continuous time, you have to replace your n with t over t, capital T. Okay, so means what you have to do first, what you have here is actually in frequency domain form. So you have to convert this frequency domain form become time domain form. Okay, so you have to convert from frequency domain to time domain. Okay, this is frequency domain to time domain. Okay, so for you to do this one, you have to refer to table number 1 and 2. Okay, so from here you know that pi delta omega blah 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 plus pi delta omega blah blah blah, this one is cos signal. Okay, so what's left is actually your amplitude 3.2 over t cos 0.2 pi n plus 0.6 over t cos 0.8 pi n. Okay, if you're still confused, okay, pi delta blah blah blah, this one is belong to cos. Pi delta blah blah blah, this one is belong to cos. Alright, so because of this, we have this one. Okay, and then this is in discrete time signal. So for you to convert to continuous time signal, you have to replace your your n with small t over capital T. So you will have yt equal to 3.2 over t cos 0.2 pi. You replace your n with, so you will have t over t minus 0.6 over t cos okay, 1 over t is equal to fs. So you will have yt equal to 3.2 t cos fs is 500. So fs equal to 500, you will get 100, right? Okay, but don't forget to multiply this 1 over t with t and then this 1 over t with t. Again, I want to repeat again, 1 over t, this one is referred to your sample signal. Okay, yt is actually after we process the signal, so we don't want your 1 over t anymore. Okay, 1 over t is just for processing part. Okay, okay, so here we have your final yt is 3.2 cos 100 pi t plus 0.6 cos 400 pi t. Okay, now you need to sketch the spectrum. Okay, so for you to sketch the spectrum, you need to find the CTFT of yt. So CTFT of yt is y exponent j omega equal to, okay, so we have 3.2 pi delta, oh sorry, it is not it is yj capital omega. So we have setting capital omega minus 100 pi plus delta. So next, what you have to do is you just need to sketch the spectrum of y exponent, yj omega. Okay, so you have 100 pi, you have at negative 100 pi. Amplitude is 3.2 pi, and then you have at 400 pi and negative 400 pi. The amplitude is 0.6 pi. Okay, so last question is write the expression for Sn and Yt. This one easy. Expression for Sn and Yt. So Sn is Sn is 4 over t cos 0.2 pi n plus 3 over t cos 0.8 pi n. Your yt, it is from your y exponent j omega, yj omega. So basically, so for your yt is 3.2 cos 100 plus 0.6 cos 400 IT. Done. Okay, so means okay, this is your final example for sampling process. Okay, so I hope please give a try. Okay, see you soon. Bye. Just now you cannot see how I find A and B. So basically how to find A and B, it's coming from, okay, pi minus 0.2 pi is actually pi minus 0.2 pi here. Okay, 1 over pi is coming from 1 y over x. So you get y over pi. And then times 4 pi over t. This one is coming from the amplitude of your A. Okay, amplitude of your A is 4 pi over t, right? And same goes to how to find for B. Okay, pi minus 0.8 pi. Okay, so it is actually for the distance between pi and 0.8 pi. We want to find the difference. Okay, next y over x, 1 over pi times 3 pi over t is coming from the amplitude of your 0.8 signal, the amplitude of this signal, okay, the red color signal. Okay, so you can find B. So basically these two is actually the amplitude of y exponent j omega signal. So from here we can derive your y exponent j omega equation, which is this one. Okay, in the video I show you how to form, how cos is fine. You can get cos, okay, and 3.2 pi and 0.6 over t.